yesterday we were looking into the word embeddings, right? word2vec. We started looking into word2vec. So word embeddings are the encoded vector representation of words will try to produce a semantic similarity in the numerical representation. In word2vec, sorry, in bag of words and TF-IDF, it is semantic, sorry, syntactic, and in word2vec, glove, dark2vec, fast text, and transformer networks, it is all semantic similarity representation of numbers. So we looked into high level view of word2vec and a little bit of in-depth stuff also. Let us try to look into the look into these highlights one more time and then jump into the more theory, because we need to understand how exactly this skipgram works, and there are some heuristics and stuff we need to understand that, and then we'll look into the code. Most probably tomorrow we'll look into the code, or we don't, maybe most probably tomorrow we'll look into it. So word embedding is a vector representation of words. Okay, that should be clear. Word embeddings means vector representation of a word. Word2vec is more sophisticated word embedding technique, right? This technique is based on the idea that words that occur in same context tend to have similar meaning. Words that occur in same context tend to have similar meaning. So the vectors are going to be close. The word for the words which occur in same context, the vectors generated by word2vec are going to be same. And in 2017 this was new, and that time this is the only way to convert. But now we have many ways. Glove is there, transformer network is there, all that stuff is there. Better than word2vec. I would say better than word2vec. Okay, so but this is the basis. If you know this, rest all are easy to understand. Okay, word2vec model will be trained on generated supervised dataset. That we know, right? How we generated that supervised dataset? By taking a window size of 2, I have generated a supervised dataset, right? So I have taken each word, and that each word as an input variable, and the surrounding words as the output variable. How many surrounding words? Window size, left and right. Okay, and bag of words TF-IDF vector representation failed to maintain importance of context. Word vectors generated by word2vec carries the context and reduces the dimensionality of the vector. Word2vec is shallow neural network. We know what is shallow neural network, right? Only one hidden layer. Okay, and then yeah, outcome is weight matrix. We have seen that also. I'll talk about these things today, the other things. But one point we need to remember is this is not a final solution or one-shot solution for all the problems we get in text. Right? It cannot solve all the context related. It cannot represent data as it promises, right? So the word2vec will be more appropriate when you have singular plural kind of words, and data is kind of satisfying this condition, right? Say same context words and different same surrounding words and different context word is there in the text in most of the places, then it will actually come. Rather it will not work. So word2vec is not the final solution. It is one of the solutions. And will it solve all the problems? No. Okay, that we need to know. Okay. So now we are going to look into skipgram model. Right. Skipgram model takes the context word and tries to generate surrounding words. When I say context word and surrounding words, we should represent context word in your numbers and surrounding words in numbers. So we have taken the one hot representation of each of the token as the numerical representation. And then we built a neural network which actually takes the one hot representation of the word and tries to generate one hot representations of the surrounding words. In this process, it actually generates the hidden layer number of outcomes. This is the vector, final vector we are going to take to represent a particular word, right? We train the model in such a way that the error reduces each time it takes a word. It will try to generate the surrounding words and error reduces. We have seen that, right? Yesterday, when this 1 is there and rest all are 0, only these weights get adjusted. When the class came, if you run, if you have 1000 words, 1000 distinct tokens in your dataset, you ran 100 iterations, 100 times class comes into the network, only that set of weights associated with the class will get adjusted, and the model tries to generate the surrounding words. So that way, if the surrounding words are occurring in other place and with some other word, then it will try to generate similar vectors. Okay, only one set of 150 vectors are getting adjusted. If you take 300 nodes in the hidden layer, you get 300 dimensional vector. If you take 100 dimensional vector. If you take 10 dimensional vector. This is a hyperparameter. Okay, this is skipgram model. This is how we actually formed the data set, right? So till here we are all good, right? Any questions?
Sir, how the output value is sent, sir?
Output
So the
value?
output, I mean the y values. So these are all the x values, right?
Hmm.
The left side values, learning, want, class.
Yeah.
All these are the x values. How the y value is sent here to the model?
See, in one of the examples, right, I have taken one hot representation of the target variable and then softmax. Softmax
Hmm.
as the node, right?
Yes, yes.
One softmax node I have taken. Here, multiple softmax nodes. So multiple one hot vectors we need to send. Right? In that, I have taken softmax node with 10 as the, 10 as the classes. Right? Here, what I'll do is, I'll take, softmax node, 10,000 as the classes. Again, one more softmax node, 10,000 as the classes. Again, one more softmax, one more softmax. I'll connect this layer to all these four. Got it? This layer will get this as input. This layer also will get this as input. This layer will also get us this as input. This layer will also get us this as input. Four output layers, same hidden layer input will pass. And for those four, we'll pass these four one hot vectors. I think you are connecting, right? Dots. Yes, no? Shall I show you?
Yes, sir. Just trying to visualize, but
I'll show you. Give me one second. Do you remember which file I did one hot representation? Maybe custom cast function, I think. Right.
Sir, it's I think 42, sir. No, because it's one day back.
One, I think here. See this category, right? I converted this into categorical y variable. So it will have, 10 columns and this many rows. Right? See here I actually passed the dense layer, right? So in this case, right, what we need to do is we need to take, oh my god, in this case we need to take and this should not be the sequence class. I think I need to change a lot. Give me 1 second. Maybe 42 class will be better, sir, because I would have used a model class there. Let me see. So 42 and 40, 41. But this is again that CNN class, right? So maybe I have to do it like this. Model is equal to model class, and then input layer, right? Input is equal to input of 28 by 28, right? I think I am writing it correctly. Give me 1 second. I think here, yeah, model. Yeah. Like that, and then I think model in the end we have to take. Right here you will have layers like yeah, dense layer. Right, input you need to pass like this. Okay, and then units, number of units, activation function like this. Right. So next layer. So this is layer 1. Okay, layer 2. I am just putting multiple layers here. Maybe in this case, right, we'll have only one layer, right, in the word2vec thing, right? So 150, and then I'll take softmax layer sm1 is equal to keras dot dense softmax here 10,000, right? And then this is L1, right? SM2, SM3, SM4, right? For all, it is going to be L1 only. And then here we should put
sorry, the output should be only four values, right?
SM1, SM2. No, not 4 values. Output will generate 10,000 numbers. Each softmax will generate 10,000 numbers. Probabilities. 10,000 probabilities it will generate each node, and then you take a threshold and make rest of the only one number 1 and rest are 0.
But how many softmaxes is it going to be 4 or is it going to be?
That's it.
Yeah, 4.
That's how you need to build this network. Got it? L1. Yeah. For all we are passing this L1 only. Right? You need to build a cost function that actually tries to check, each of this outcome and, tries to compare it with the target variable. That's a bit, yeah, no need, because we are passing 4 outputs, while fit also, while fitting also, we should actually pass 4 inputs. Where is that fit? Give me 1 second. So I think fit also changes. Give me 1 second. Model definition is that one. And then, here, while fitting, right, we should actually, here we should pass 4 values. 4 y1, y2, y3, y4. Like this you need to pass. Got it? Then categorical cross entropy will work, the cast function.
So what are y1, y2, y3, y4, sir? Are those vectors?
y1, y2, y3, y4 are those these surrounding words, deep learning from Datajango.
So those are vectors of the dimension 10,000.
Every word is a dimension 10,000 vector, right? Because 10,000 tokens are there.
Yeah.
Right?
Yes.
So that's how it should be. Okay?
Yeah.
Yeah, this is how you actually need to think and, kind of. If you are interested, right, I have one exercise that actually needs this kind of complex network building activity. So, once after finishing this word2vec and a little bit of introduction to transformers stuff, right, I'll show you that example. So, if you do one of these, right, you will get a lot of confidence. And there will be problems, I have explained like this, but maybe cast function may not work a little bit here and there, and the brackets may not work, right? Things like that will happen. And one more problem is that data set is going to be huge, and you cannot save it into memory. Then you need to load it from the disk. There will be problems. So data TensorFlow has got a class called as dataset. Using that, we may have to do some things. So practical implementations will have some hiccups here and there. When you start doing it, you'll know. Okay. So that is clear, right? Can I move on?
Yes, sir.
Sir, one question, sir. What loss function we need to use for the word embedding, sir?
We can use this cross entropy, categorical cross entropy.
Okay.
Because we have 10,000 vectors as input, and we are getting 10,000 dimensional vectors probabilities as output, right there, right?
Yes. Okay.
On a small data set or on a small text, we can build this network and experiment, as you said, right? Maybe one paragraph, maybe 20 words, and then try to build this network and experiment it and see how it's actually doing. Okay. So there are problems in this network. Okay, that we'll understand. So there is a technique called as negative sampling. Why negative sampling? If you look at this last layer, right, softmax layers, here 10,000 classes are there. It need to calculate. It need to have 10,000 different sets of 150 dimensional vectors, weight vectors. Do you agree? How softmax works? How softmax works? On a 10 class data set, it takes 10 sets of um, uh, 10 sets of weight vectors, right? 784 dimensional weight vectors. Do you remember? On the numerical handwritten digit data set. Softmax, how did it work? Do you remember? No. See this? It actually took right 785 thetas, right, for class 1, 784 thetas for class 2. Like that, 10 classes, 10 784 thetas sets it took. Right? In our word2vec, right? If you look at the softmax, it's actually trying to classify 10,000 different classes. So it will have 150 dimensional vectors of 10,000. Okay. So it's going to be a huge calculation. If you look at this softmax regression classifier's calculation, it's going to be a huge calculation for each of the softmax. There are 4 softmaxes. So practically, when you try to build this kind of a network on a huge data set, it's going to take a lot of time in training. So these guys have came up with a technique called as negative sampling. Okay, there is one approach called as hierarchical softmax, which actually tries to split the data into multiple hierarchies, like kind of a tree, and then tries to make predictions, and on those splitted data again it tries to make softmax. It's like you have 10,000 numbers, you are splitting that into maybe 100 on each 100 you are doing softmax, and then you get 10,000 means 100 into 100, right? So 100 again, 100 values you get. On those 100 values you are going to do softmax again. So that's how you are reducing the complexity. That is hierarchical softmax, but this is not used much. So negative sampling and hierarchical softmax both to improve performance of the model, improve the performance, or what you say, reduce the time it takes, right? So time complexity we are trying to reduce by using negative sampling. Okay, so how negative sampling works? Previously we have seen that word2vec is going to form a data set like this. Why am I taking this much time on word2vec? Is it is one thing is it's very interesting, and second thing, these techniques can be used in other problems, solving in other problems. We may build a neural network, or we may actually form data sets like these and build neural networks and work. So this is a very intelligent technique, right? So we took context word and surrounding words and all that, and we formed it. But in negative sampling, right, we will do in a different way, right? This data set formation, why, what is this data set? This is the data set which is basis for this network to generate appropriate weights, right? Appropriate weight matrices or embeddings for each word, right? So in negative sampling, the data set is formed in a different way. Context word and the target word. Within the context, right? Within the window, right? This class is the context word. Within the window, we'll take one word. Outside window, we'll take 4 words. Right? This 4 is a hyperparameter. I'll talk about that. Right? So here I said window size is 2, right? And there is class, the context word, right? See this here, deep learning class from Datajango, right? So deep learning from Datajango are the surrounding words. Class is the context word. For class, we have 4 surrounding words because window size is 2. This is a hyperparameter. So out of these 4, I'll take one and create a record with target variable as 1. Okay. For the class, I'll take 4 different words from out of the context, out of the surrounding words. Okay. So what are out of surrounding words? If you take that part out, right, these are all the surrounding words. I want to take are the surround, the out of surrounding words, right? The beyond window. Okay. I take those words and put 0. Okay. This is how I form the whole data set. Now for class, I have shown it here. For I also, I'll take the same way, right? Within window, I'll take 1 word. Outside window, I'll take 4. Randomly, I'll pick. Again, for want also, within window, I'll take 1. No, outside window I'll take 4 randomly. I'll pick for take also. Like that I'll form a data set. Okay. What is the use here? Instead of forming a softmax network at the final layer, you can actually do a binary class classification here, right? Every you pass these two vectors, 10,000 vector, 10,000 vector, one hot vector, and you try to do a logistic regression. Again, 10,000 vector, 10,000 vector logistic regression, 10,000, 10,000 logistic regression. That way you can actually generate the word vectors, similar word vectors easily with less, less power. Did you get this concept here? Any questions? We are forming the data set in a different way. On this formed data set, we are going to build a network. This is the actual word2vec skipgram model. To improve performance on skipgram model, we are taking negative sampling. This is the negative sampling technique. Right? These are all the negative samples. This is positive sample. Within window, one word. Outside window, k number of words. Here it is 4, but you can change it. Okay. So for window size k, we need to build k plus 1 models. That I'll explain. That we need to build k plus 1 models of target variable logistic regression. Okay, one logistic model for the word within the context and k outside the context. Okay, outside the context or outside the window. Okay, here we need to build 5 logistic models, right? But k is equal to 5. Like you need to choose k is equal to 5 to 20 for the smaller data set, k is equal to 2 to 5 for larger data sets. Why this is? Can you think a little bit? Now this 4, I have taken 4 here, right? How many outside window words should be chosen? I have taken as 4. But it should be 5 or 5 to 20 for smaller data set. It is saying, the theory is saying. Why? In a smaller data set, you will have less number of words. If you take window size 20, sorry, the k is equal to 20, for each word you will be forming 21 records like these. 20 records of negative sample and 1 record for positive sample, right? Even though the data set is small, even though the tokens are less, you are going to form a big data set using this 20k. Deep learning models generally are data hungry, right? That way you will be able to make the model work better. No? On a huge data set, even if you take the k size small, it will form a huge data set. Right? You don't want to create a data set that cannot be handled. So you are taking less number of k. Got it?
Sir, one comment, sir. So probably for the small data set, the reason for going for the higher number of negative words is so that it will be more accurate. That's my understanding. I'm telling you.
Yes and yes. Sir. When you
Because
have more data, right, more accuracy will come definitely.
yeah, yeah. Because if it is a large data set, because we are having so many such combinations, so data somehow accuracy will be taken care. But in case of
Yes.
small data set, maybe that is the reason why they are taking more number of negative combinations.
Yes. And one more problem with the large data sets is you have too many documents and you don't know, there will be too many combinations also of data. Right, and
Yes.
that may actually create some noise. So if you take smaller size, right, noise will be reduced. Right, you choose the negative words randomly from whole data, right? So it may choose, sometimes if you choose too many samples, negative samples, it may choose the stop words or maybe repeating words, many times. That way, the data set is going to become noisy. So if you take less number of samples from the outside window, the noise will reduce also. That way, the data set gets created properly. Huge number of records anyway will come, and accuracy will improve, as you said.
Clear,
And
sir. Clear, sir.
So that is, the negative sampling, how actually do. This is where we may get confused. Okay. So I said that we need to form. Sorry.
Sir. So why only deep is taken here as a target word for class?
That is random, and from within window, within the context window size, you randomly choose one word.
Okay.
Outside also you choose randomly 4.
Okay. So here we say k equal to 4, and for example, we don't have those number of words in the outside window.
We will, right? Definitely we will have, right? Okay. For I we don't have, right? Maybe we'll take whatever is there, right? Whatever is there we'll take. In this network also I said if the word is not there, we'll give zeros vector, right, as output. In that case, right, it is all, it is all like maybe you will ignore the edge words. You will not form the data set with the edge words. It's not going to harm anything because you are having a, when you are saying word vector representation or you are trying to build a neural network, you have a huge data, right? Even if you ignore the first 4 words and last 4 words, that's okay. Got it?
Yeah, so one comment on the edge words, sir. So probably in one document, it may be an edge word, but the same word may not be the edge word in the other one. That way,
Yes, and
we have some data.
yeah, we will have some data. And one more point, right? While building the model also, in the word2vec class, word2vec, whatever the module we use from Gensim, there is a parameter which says min occurrences. Minimum occurrences, if you say 2, right? At least twice the word occurred in the data, it will consider, minimum the word should occur at least twice in the data. Then only it will consider and create this data set. Rather it will not create. So these are all different caveats, I should say, and we should play with them. And it's not going to harm anything, even if you ignore the edge words. Beginning 4, last 4, or beginning 2, last 2. Got it? Okay, Nandesh, can I move on?
Yes.
So, I said one logistic model for the context word and 4 for the outside words, right? How this model is being built, I'm trying to explain. When you actually change the data set like this, you are no more doing a model like this. The softmax nodes that stuff is not going to be there. So how the model should be built? So throughout the whole internet, you try to find it. There is no explanation for this concept, whatever I'm explaining right now. Especially this is also not there. This whole word2vec, nowhere else is there. Okay, I created it myself. Okay, so this one definitely no negative sampling, definitely no example, no clear picture. Okay, so how you do it? So I said we need to do a logistic node, right? So we need to do 150 dimensional embedding. So what you do is I have taken class context word C. Okay, context word I took it as C, and there is a 10,000 dimensional vector and 150 dimensional embedding, the hidden layer. Okay, and I am passing the 10,000 dimensional one hot vector to this hidden layer, right? Random weights initially. Only these weights get adjusted, right? Only these weights get calculated, right? And we are at this place. Okay, so we call this as embedding vector. First layer, first iteration embedding vector. First iteration, random weights. Only the weights which are coming from this one will be populated here if it is ReLU, right? And then we say the context vector VC. I call this as VC, right? And I have taken one word from the target words, right? One word from the target word is one only, right? So this is the input word. This is the target word, right? So I have taken the target word, and took the 10,000 dimensional vector, again took 150 dimensional whatever, that 150 nodes, and then only the weights, random weights went in, and I called it as VW. Okay, VW. Now, if you are doing a logistic regression node, right? What is the formula for logistic regression node? 1 by 1 plus e power minus z, right? Minus z, right? Or you can say 1 by 1 plus e power minus theta transpose x. Do you agree? Theta transpose x. Do you agree? Theta transpose x, this thing.
Yes, linear combination.
Linear combination, right? So in this particular setup, or for the first record, or for this particular set, what are we trying to find? What are we trying to find in this first set? For the class set, of negative samples and positive samples, using this particular set, what are we trying to find?
Numerical representation, vector representation.
Numerical representation for class, right? Numerical representation for class, vector representation for class. Do you agree?
Yes, sir.
So in this diagram, right, if you pass class vector and trying to train the model, you are trying to find the numerical vector for class. 100 iterations you do, 100 iterations, this class comes, each time only that set of vectors get adjusted, right? So here also we need to do the same thing. When the input variable is class, output we don't care, whatever, we are trying to generate vector for the class. So what we should adjust now, when class comes, what we should adjust? Only this set of weights we need to adjust, right? Do you agree? Only this set of weights we should adjust. Do you agree? Yes, no? No, no?
Yes, yes.
Right? So VC is what? That set of vectors, right? That set of weights, right? Right? When you adjust those weights, then you will get a proper embedding or the vector representation for this class. So I took VC in the place of theta and VW in the place of x. Theta transpose x. Back propagate, theta gets adjusted. Again you do forward propagation, theta transpose x. Back propagate, theta gets adjusted. Right? Like that it is. Got it? How to build this network? Don't think about it. Because you need to use model class and build. No need to build it. Basically, if you want to build it, right, you need to do model class and the approach I explained previously. You need to do that kind of a manual hand coded model you need to build. If you want, you can build it. I can help you, but I did not do code example on these. Maybe better I do code examples also, but I'll do it later. But you did you get the gist of it? Did you get it? No? Let me show you another diagram. See this here? Right? These are the five iterations of the class as input and the negative sampling output, right? So I took VC here and then VW and passed it to the logistic regression node by taking the VC outcome as the theta and VW outcome as x. Okay. For the second record also, right, for the second record means in this particular thing, right? For the second record also I have taken VC's outcome, the embedding as the theta and VW as the x. And when you do back propagation, right, this gets adjusted. The back propagation this gets. So for all five, for the input words shallow neural network outcome is going to be considered as the theta, The other word, the the target words, right? Target words. These target words, the 150 dimensional vector is taken as the x, right? In the next iteration, if 5 iterations are done, these 5 iterations are done, then the next record is going to be deep, maybe, right? Deep's 150 dimensional vector is going to become theta, and the surrounding words are surrounding word or the out of window word vector is going to become the x, right? We are trying to see, right, y variable is already there, either 1 or 0, right? We are trying to adjust this, adjust these vc's, adjust these vc's in such a way that it generates 1 or 0 depending on y variable. That way, this is going to be a representation of the 10,000 dimensional one hot vector. 150 dimensional vector is going to be a representation of the 10,000 dimensional one hot vector. Got it? Got it?
Yes.
So very simple it is, but when you look into the theory, right, it generally is not that convenient. Try to look into the Google and see if you can find, maybe if you don't understand this, try to find better explanation. If needed, right, we'll discuss tomorrow. Okay. So it needs a little bit of thinking, right? You need to think from your end also. It is not just that I can actually open everything and put it into whatever. Am I recording? You are recording. Okay, good. So, Prudvi, I think you need to watch the weekend videos. It is very important content is being covered in the weekends. Unfortunate, but no, there is no other way. I was actually a bit busy and couldn't take classes in the weekdays. But take time, okay? Take time and look into the videos. That's whatever we are covering now is all industry ready stuff. Till here we covered theory, I would say, but from now whatever we are covering is all industry. So it is like it took 4 months of preparation to take you to a place and then explain these things. Like we cannot explain these things in the beginning of the maybe 1-2 months of the session, the classes. I hope you understand. Okay, Prudvigar. Hope you, I think you got it. That's okay. Okay, so now the K, negative sampling words, how to choose it. Okay, I said for the smaller data set, K should be big, and bigger data set, K should be small. There is one more problem with it. When it is actually choosing these target word and the within context and outside context, when the data set is too huge, when you are picking these words randomly, the take I want to randomly, it may actually pick the same word multiple times because it is generating, maybe some word is many times repeated. There is a chance, right? So that's going to cause problem. That's going to generate the vectors which may not be that appropriate. Okay. To avoid that problem, there are 3 solutions. Choose words that appear frequently in the data, right? This may not be appropriate as stop words may appear more frequently than the other words, right? This is not appropriate, okay? And choose words with a uniform distribution, right? Uniform distribution means there are V number of vocabulary. Vocabulary means distinct words, okay? So 1 by V is the probability. If some words probability is 1 by V, right? There are 1,000 words. The word is occurring 10 times, right? There are 1,000 distinct words, and then the word is occurring like uh, there are 10,000 distinct 10,000 tokens in the data. Sorry, let me correct it. 10,000 tokens in the data, and then 1,000 distinct words in the data, vocabulary, 1,000 distinct words. Uniform distribution means the probability is 1 by 1000, right? If a word is occurring 10 times, choose that one. Choose that one as the surrounding word, right? From K, from K surrounding words, right? To choose that word. That's the next thing. Got it? That way, right? You are actually choosing a most frequent word which is outside of the window, right? That way, the model will understand, or model will generate a vector which is far from that most frequent outside word. Getting it? Getting it? Most frequent outside word, the inside word, the context word should be far from it, right? The vector generated will be far from that outside word. Okay, uniform distribution words you take, and then close to uniform distribution words as the negative samples, and then try to build the model. Okay, the third thing is heuristic. You know what is heuristic? You know heuristic, right? Meaning of heuristic? Yes, no? Heuristic means somebody actually experimented with this with different numbers and it worked. They don't know why it worked. It is all science. For everything they will have reason, but in between, right, they'll have constants. That's science. Okay. So it is like this. Okay. So an approach, an approach between 1 and 2, right? This is frequency of word I divided by sum of f of so sum of frequency of word j, right? Word j is um, j is the range between 1 and vocabulary, right? Frequency of word I. So it is like you take unique words, right? I said 1000 unique words are there, and for the current word it is 10. 10 divided by 1000 is going to be 1 by 100 to the power of 3 by 4. Right? Any word you take, right? Any word you take, you calculate this probability and put 3 by 4, whichever actually gives you, right, 3x, right? If you take these three words, each word, when you substituted the probability into this formula, you got 0.92, right? Constitute 0.16, bombastic 0.0032, right? Bombastic is now 3x more likely be sampled, right? Where ease is so when you look at this 0.01 and 0.032, this is actually 3 times, right? When you applied to the power of 3 by 4, it actually came 3 times. So this is the most probable one. You calculate the probability and then try to divide the outcome with your original value. Whichever gives you highest score, you choose that word as the negative sample. Got it? Why? It is all experimental. They tried with different numbers and it worked. Got it? Yes, no?
Yes, sir.
Yeah. So I took this whole theory. I looked into this the Stanford paper. You can actually look at it. It's a simple one. That only I think 3-4 pages will be there. Why is it taking this much time? So now, right, from now on, you actually have to look into the research papers also. If you are trying to work with, object detection or some kind of project, right, we should be looking into research papers and taking some ideas and trying to implement them also. So if you can do this intense activity in AI, you will have bright, very bright career with high paid salaries. And, apart from all that, right, it is exciting. So, let it open, I'll show that. Okay, that is word2vec theory. Let us look into a code example. Very simple. Code examples are very simple. So this is the word embeddings, right? So I have taken this IMDb dataset, right? You have it, I hope that you downloaded it and kept it into your dataset. I'm not going to run this because it's going to take a lot of time. So I've taken already saved corpus in our bag of words. We did, stemming corpus and all, right? I have saved. I've actually saved it, and I'm creating a uh, list of lists of tokens. So from here till here, that is one review converted into tokens. From here till there, it is another review converted into tokens. From here till there, it is like I have taken only 3 reviews or 5 reviews, I think. There is some mismatch. Okay. And then I have created a word embedding here. See this? I am training my own word embeddings. There will be word embeddings already created that you can pass your words and get vectors, but they would have trained on their own data. Okay, but if you want to create a semantic similarity of your data, your words, then you need to form this kind of list of lists words, and then in GenSim we have got word2vec class which actually takes the embedding size, right? How much dimension it should give. Window size 10 I gave, left side 10, right side 10 words it will consider. Min count 2, at least word occurs twice, only then we will consider. SG is equal to 1, skip gram. Okay, negative sampling anyway default, I think. NS or some, workers, the processes, how many parallel processes should be running. And then build vocabulary and say sentences is equal to these, whatever the tokens, list of lists you need to pass. And then, you run this, it will actually create the vectors. And then, vocabulary. So how many distinct words it found? 32,104. And what I did here. Yeah, now I am training actually. This is the training. Model.train. I am passing the data, corpus data. Total examples is the length of that. That how many sentences we are passing, how many lists we are passing. And then epochs is equal to 20. Right? Back and forth, 20 epochs it will run. Okay. And I saved that whatever word2vec model. Now I am actually looking into vocabulary, right? Vocabulary, I took word, right? Um, count less than, count plus 1. I think I have taken 150 words there, so don't be confused with this 150. I would have taken 1 hour. So for I there is a vector generated. For rent there is a vector generated. Right? For bit there is a vector generated. For like every word there is a vector generated. Can we see those vectors? Yes, we can. Somewhere I would have shown it. Okay. So you need to say VW, um, VW model.vw of the word will actually give you the vector. Numerical representation also you can see. I'll show that in later classes, or you can experiment also. Right. So I have taken TSNE. This is like PCA, right? Principal component analysis kind of dimensionality reduction technique. I am taking this 150 dimensional vector and reducing the dimensionality to 2, and then trying to plot it and see whether related words came close or not. Let us see. Related words came close or not. I don't know whether you can see. Verizon and America came close, and problem and idea came close. Haphazard and baddie came close. Rent and save, right? Maybe somebody would have written like, I did not pay rent, or maybe rent reduced and I saved money and things like that, right? So they came close, but they are not similar words, right? They are not similar words, right? Fall and apart, right? They are similar words. See this? Fall and apart are, kind of similar words, right? The fall, it's like fall apart, and that word will come, right? So If you run more iterations, more epochs, right, it may actually generate more appropriate word embeddings. And the second problem is when you actually reduce 150 dimensional vector into 2 dimensions, there will be a lot of information loss, right? So because of that also, this graph is not actually going to show things well. Okay, the appropriate way to look at it is you take a word and then try to calculate a cosine similarity with the other words, right? There are 32,000 vocabulary, right? Take first word, take the cosine similarity with all the 31,000 words, and take the minimum cosine similarity words and see whether they actually are similar words or not. Okay. In word2vec, there is a method called a similar. You take model.word2vec.similar and pass your word, it will try to give you the similar words. In a way, it actually doing the cosine similarity between the word you passed and the other words present in the data. Got it? Building models and working with code is very simple. Understanding theory is very difficult. Why do you need to understand theory? If you have to understand all these parameters, right, you need to understand theory. What is HG, what is min count, what is size, what is window, what is workers, right? If you look at the API, right, you will find many more things there. And if somebody doesn't know what is word2vec, they may use it, but it's not optimal usage. May not be. Got it? Right. So tomorrow, right, I'll stop it here, and tomorrow I'll explain the glove model, which is based out of our. I showed you SVD based word embeddings, right? Did I? Did I show SVD, singular value decomposition based word embeddings? No.
Yes, sir. I don't think we covered it.
No, sir.
Yes, I am not remembering it.
Yeah, I'll show tomorrow. Yeah, yeah, I'll show tomorrow. Maybe the file is missing. Topic modeling, I showed SVD. Yeah, I'll pull it in and explain. Okay, so let's meet tomorrow, and let us start with that word embeddings using SVD, and then we'll look into glove, because glove is a mix of the word2vec and the word embeddings using SVD. Okay, and then